You deployed an AI model last month. You tested it, it passed. But what you did not know is it was poisoned before you ever downloaded it. This is not a runtime attack. No hacker touched your server. No vulnerability was exploited. The damage was done during training by whoever controlled the data. The model shipped with a backdoor and it benchmarked perfectly. Three attack vectors, a backdoor that activates on a single trigger word, real incidents, and the defenses that actually work. We will cover it all. Let's go. Machine learning models learn from data. Whoever controls the data controls the model. The attacker doesn't need access to your server. They don't need your code. They need to contribute a few examples to the dataset you are training on. That's it. A few carefully crafted data points, and the model learns exactly what the attacker wants it to learn. Clean data, the boundary is correct. Three poisoned examples added. The boundary shifts. The model now misclassifies exactly the input the attacker chose, not randomly, precisely. And it does so with full confidence. You did not make a mistake. You trained on the wrong data. Same outcome. Your model didn't get hacked after deployment. It was poisoned before you ever downloaded it. Three ways this happens. 1. Dataset poisoning. You are training on a public dataset. The attacker contributed to that dataset 6 months ago and waited. Your model learned from their examples you never knew. Second is supply chain poisoning. A model on HuggingFace, 50,000 downloads, looks legitimate, benchmarks well, buried inside a backdoor trigger. You fine-tune on top of it. The backdoor survives fine-tuning. Now it's your model, your problem. Third is federated learning poisoning. 10 hospitals training a shared medical diagnosis model. One participant is compromised. Their malicious updates get averaged in with everyone else's. The model ships to all 10 hospitals. Wrong diagnosis at scale. You did not write the bug. You did not deploy the bug. You trusted the wrong source, and that's the attack. The most dangerous variant. The model passes every test, every benchmark, every evaluation. It behaves perfectly until it sees one specific input. A trigger word, a pixel pattern, something invisible to you. But the model was trained to recognize it. And when it appears, it misclassify. Leak data, approve the transaction on command. 10 inputs, all correct. The 11th has the trigger. The model says safe, but it isn't. You can't test for a backdoor you don't know exists. The attacker decides when it activates, not you. This already happened multiple times. 2023. Backdoor model on HuggingFace, downloaded thousands of times. Nobody checked what was inside. Microsoft A, poisoned by public interaction. 24 hours from launch to shutdown. The training data was the attack surface. GPT style models, poisoned with 0.1% bad data. One example in every 1,000. Undetectable without knowing what to look for. 1 in 1,000. That's the entire attack. That's all it took. None of these required a hack. No server breached. No code exploited. It is just trusted the wrong data. You can't prevent what you don't audit. 3 defenses all start before training. Data provenance. Every training example needs a source. Who created it, when, where. If you can't answer that, you don't know what your model learned. Model scanning. Virus total for models exists now. Run it before you deploy anything you didn't train yourself. 50,000 downloads mean nothing if nobody scanned it. Differential privacy during training. Makes it mathematically expensive for any single example to influence the model. The attacker needs more poison. More poison means more detection risk. You review code before merging. You scan packages before installing. Your training data deserve the same, man. You already manage code dependencies. You already scan NPM packages. You have a new dependency now, and most teams are not auditing it. That HuggingFace model, who trained it, on what data, was that data audited, does it have a lineage you can trace? If the answer is no, you are running untrusted code at the center of your system. One poison model upstream. Every application that fine-tunes on it compromised. Every user those applications serve affected. The blast radius is your entire stack. NPM audit runs automatically. Model auditing is still manual. That gap is where attackers live. System design interview. They ask about your ML pipeline. Most candidates talk about accuracy. You talk about trusted boundaries. That's the difference. Pattern 1. Data provenance pipeline. Every training example has a source. Cryptographic hash on every dataset. Immutable audit log. You can trace any model decision back to the data that caused it. Pattern 2. Model supply chain verification. Treat model downloads like code dependencies. Signature verification. Non-publisher only. No unsigned models in production. Ever. Pattern 3. Canary inputs. Non-trigger patterns in your test suite. If the model behaves differently on canaries, something was injected. Quarantine before deployment. Pattern 4. Data trust boundaries. Public data and private data never mix without sanitization. Different sources, different trust levels, different pipelines. Pattern 5. Production drift monitoring. Watch prediction distributions in real time. Statistically anomaly on specific input patterns. Alert. Quarantine. Investigate. Backdoors activate in production. That's where you catch them. Training data poisoning, the supply chain attack of AI. If you find this useful, please subscribe. Stay secure.